Okay, let's take a look at the very back on notes 1.5. E is a real number constant found in some types of mathematical problems. Remember we discussed E whenever we were doing continuously compounded problems. We had that E in our formula. So it says use your calculator to find the value of E. So remember I told you when we went over it the first time, it's just like pi, it represents a real number. Okay, so if you go to your calculator, excuse me, you're going to do second divide, and then that's E. Press enter. So it says E equals 2.7182881, etc. Okay, we'll go ahead and put 2 there. Alright, so that's E. E is just like a constant. Okay. Alright, so we're going to sketch f of x equals e to the x power. So this is exponential, what we've been going over. Your base will be 2.7182882, etc. Okay, so that's my base. It's going to look like just like all the other exponential graphs we were looking at. So go to y equals. We're going to type in. Now you can use the e to the x power, which is second ln, which is natural log. So e to the x. Or you can do the second divide and then use the caret key. Okay? Alright, we're going to go to the table. Let's just go from -2 to 2. So when x is -2, we'll round to 2 decimal places, 0.3 or 0.14. -1 is 0.37. 0 is 1. 1 is 2.72, and 2 is 7.39. Okay, so we're going to go ahead and graph those points. So we have -2.14, -1.37, 0, 1, 1, 2.72, and 2, 7.39. Okay, so it just looks like all the other exponentials. Notice that it's increasing from left to right. That would be a growth because that e, remember, is 2.718. Okay. All right, so we discussed that whenever you're finding the inverse of an exponential, you get a log. When the base is e, it's a natural log. Okay, so you're going to write ln of x. Okay, so that is the inverse. Instead of writing log, you're going to write ln. That's when the base is e. If you have a natural log, so I want you to write natural log here. The base is not going to be there on your log. The base is e. So that's why you're going from e to the x to natural log of x, because that base is e there. Okay? All we have to do here, we could type it in, because we can type in natural log on the calculator, but we could just also just flip the points. So 0.14, -2, 0.37, -1, 10, 2.721, 7.392. Alright, we're going to draw our y equals x line. This natural log function should look like the logs that we've already looked at on the front. So we're going to have 0.14, -2, 0.37, -1, 10, 2.721, and 7.392. So notice that it's approaching the y-axis here because it's a log function. So this was the inverse. Okay. All right, so let's look at the relation, which is the original. So the domain, notice the domain, it's going to be all real, or you can do negative infinity to infinity. And then your range, if you look at the y, it's everything greater than 0, or you can use the interval notation. So either way. Now if you look at the blue one, the natural log of x, domain is x is greater than 0, and then your range would be all real. So in all of these, when you have an exponential, domain's all real, y is greater than 0 in the range, and then the opposite of that on your log function. Alright, the next part, we're going to use a graphing calculator to solve each equation. We're going to draw and sketch and label the solution. So it's saying use a graphing calculator to solve. Solve means you're going to be finding what x equals. Okay, so in order to do that, in y1, we're going to type in the left side. In y2, we're going to type in the right side. And then we're going to find where they intersect. So find where they intersect. So go to y equals. We're going to type in, we already have that, but we're going to retype in second natural log, which is e to the x. And then my right side is 1/2. We're going to graph it, and we're going to find where they intersect. To do that, you're going to do second calc intersect, which is 5. Press enter 3 times. We're going to sketch our graph here. So you're finding the intersection point, which is negative 0.69. We'll run to 2 decimal places, 0.5. Okay, so you're solving it. We already knew that y was going to be 1/2 because we typed it in y2. Okay, so you're solving, you're just finding x. X equals a negative 0.69. Okay, so 7, we have log of x. Notice that we're missing a base here. Okay, this is called a common log. You can plug in a common log on the calculator. So even though there's not a base there, we know base is 10. Okay? Alright, so we're going to type in y1. We're typing in the log, which is right below the x squared button of x. And then our y2 needs to be negative 1.2. We're going to graph it. Should be approaching the y-axis because it's a log. And then drawing that horizontal line there. We're finding where they intersect again. So second calc 5. Press enter 3 times. Repeat that. Intersection would be 0.06, negative 1.2. We're solving for x, so x